All right.
Is it in the study hall room?
Yes.
Okay, thank you.
Uh-huh.
Good luck, girl.
Today, does anybody need that wasn't here when I passed out the review packet?
What?
The review packet? Yes. Yeah, I'm just checking to make sure that, like, because I don't know, remember if everyone was here or not when we even talked about it. I'm just trying to remind, But yes, if you lose it, there is an extra copy on. You can get an extra copy off the OneNote. Okay. Today is going to be a little bit of a hodgepodge of stuff that we're going to do. So I'm going to talk about some simple solving problems. Do that for 15 or 20 minutes. Then we're going to give you guys some time to work on your Delta Math and or the 47 through 62 problems, whichever one you feel like doing. And that's my plan for today. Everybody's all right? Well, I've maybe talk for 15 or 20 minutes, and then you guys have the remainder of the time to work on your stuffs. Okay? Yeah, we did about half of those. So, up into this point, we've done we've done stuff like this, right? We did this in chapter 4. Hi.
Do you ever have sheets?
They're on the test.
They weren't on the stapled or anything with it.
They're stapled to the back of the test. If you're going on Kairos, it's stapled on the back of the test.
Okay.
All right. Right, so we did this on chapter 4, right? What we're going to change here is we're going to extend this interval to include up to things from 0 to 2 pi. So what is that going to mean for us? Instead of getting only one answer, we now have the possibility of getting more than one answer. Now this problem is fairly easy because I'm just going to go to my unit circle and look for where the y is 1/2. Once you take your identity sheet and flip it over and look at your unit circle and tell me where the y coordinate is 1/2. Why am I looking at the y coordinates? Because it's signed. So if I look at my unit circle and I look for where the y coordinate is 1/2, what angles did we see?
Reagan's was there, but mine wasn't.
I'm looking at the list. Oh, I see. You're over here. All right.
Thank you.
Mm-hmm.
Good luck. Thanks.
All right. So when you looked at your unit circle, where was y equal to 1/2? pi over 3. Okay, is that the only place? Where else? I think you mean pi over 6 then, and 5 pi over 6. I think pi over 3, the x is 1/2. So we have two answers now, right? Everybody's okay there? What if we had this problem? What are we going to have to do to start this? I need a regular trig function by itself. Right now, what do I have? Cosine squared. How do I get rid of the squared? Yeah, we'll square root both sides. So that's going to reduce down to cosine. What is the square root of x? Or I'm sorry, square root of 1. Plus or minus 1. Very good. So far, so good. So now I'm going to go to my unit circle. And what am I going to be looking for? The x equals 1 or -1. So what is the angle when x equals 1? I'm going to change my variable here. I'm going to call these guys thetas. This is getting confusing because I have an x as a variable, and then the x on the coordinate on the unit circle is getting confusing. Okay, who's got it? Nope. That would be tangent. That would be y over x would be 1. Okay, so 0, and then pi. But careful with the inequalities here. Could also have 2 pi, because 2 pi is allowed, right? That's the same spot as 0 on your unit circle, because those two angles are, what do you call it when they're in the same, the terminal side is in the same spot? Coterminal. What are we thinking here, fella or ladies and gentlemen? Is this okay? This is just a small jump forward from what we've been doing. Just a little tiny jump. Okay. What do we want to start by doing? Okay, getting a tangent by itself. So we'll divide both sides by 3 to start. Okay, great. Then what? What do we have to remember when we square root both sides? Plus or minus. And then how do you do the square root of 1/3? How do you square root a fraction? You square at the top. What's the square root of 1? And then the square root of 3 doesn't simplify, so we just leave it like that. Okay. So now what are we going to do? I mean, you can. I wouldn't worry about it because this is not a final answer. If it's not a final answer, I don't care if there's a radical in the denominator. On the unit circle, what is tangent? Okay. Do you see a place where y is 1? And then x is root 3? You shouldn't, but you should see something that's close. Sydney, do you see it? You were shaking your head when I said you should see something that's close.
Oh no.
Oh, okay. Do you see that there's something where you have the x or the y is 1/2, 1/2, and a place where the x is square root 3/2. So that's what we're going to be looking for. But remember, oops, gosh darn it, this is plus or minus, right? So we could have where both of them are positive, where one of them is negative, but the other is positive, and then reversed, and then where they're both negative. Is everybody okay with that? Because of the plus or minus, the fraction can be positive if they're both positive or both negative, and the fraction can be negative if the numerator is positive and the denominator is negative, or the denominator is negative and the numerator is positive. I think I said that the same way twice. I didn't mean to do that, but you're shaking your head already like you got what I was saying. All right, look them up. It's taking too long. Pi over 3, yep. What else? What's the next one? Yup. What's the next one? And what's the last one? Yup. So that one had 4 answers, right? So far, so good? What are we at? Letter D or something? God bless you. How about this? Sine theta times cosine theta equals cosine theta. Who has an idea of what we could do first? What like terms do you see to combine? Well, the term on the left-hand side is sine theta times cosine theta. It'd be like saying xy equals x. The x's aren't like terms because you don't have x, like 2x and 3x, you have xy. And you know what I'm saying, Nora? Does that make sense? Okay. I'm not going to use an identity to do this at this point anyways. Because Q1 I need tangent or cotangent, or tangent to do, right? Or a fraction. Jeepers creepers, are you okay? No. Okay. Try to get there though, huh?
Okay, I can't control my.
Okay, so in general, I want to get all the trig stuff onto one side. That would be my first step. How should I do that? So I want all these trig functions on one side. I want all these trig functions onto one side. How am I going to accomplish that? Definitely don't want to divide, because if I'm dividing by cosine theta, for example, that could be 0, and now I just divided by 0 and lost solutions.
Sorry.
It's all right. Well, adding's not going to get... You want to subtract.
Yeah.
That's what you mean.
Yeah.
So let's just subtract a cosine theta from both sides. So far, so good. What algebra thing can I do here? Think about this like a simplifying problem. The cosines don't cancel because, again, like we said before, that's like xy minus x, right? There's not like terms there. Nope, they're not like terms. That's like one term, that's another term. Let's think about it this way. If I had like 2x minus 2, what could I do with that? Nope. Well, here, because it's like a variable, right? What? Same, it's xy minus x. I was trying to make it easier, but you're not letting me. That's okay. It's my fault for picking a bad example. What can I do with xy minus x? What algebra thing could you do to this? Last year in Algebra 2, you guys solved polynomials and quadratic equations, right? Those would have been things that you did in Algebra 2. In order to solve those two things, what did you have to do as your very first step? You got it equal to 0, right? You had to make them equal to 0. That's what we just did as our first step. What was your second step then after you got it equal to 0? Do you know what I mean when I say polynomial or quadratic? It starts with the letter F. That's what I'm looking to do here. How can I factor? How can you factor sine theta cosine theta minus cosine theta? How could I factor xy minus x? Great. So there you go. Okay, when I do that, what's left after I factor the cosine theta out? Well, distribute it back through. If you don't have the minus 1 there, are you going to get the same thing that you started with? Definitely not. Yes. 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 That's how you do a greatest common factor. Okay. Again, going back to Algebra 2. Going back to Algebra 2. You had a quadratic. You got it equal to 0. You factored it. What do you do next? This is good ACT review, if nothing else. You can't add 1. If you distribute, you're back to where you started. Yeah.
What was the question?
So let's listen again. Last year in Algebra 2, you solved quadratic and polynomial equations. The first thing you did was you got it equal to 0. That's what our first step was. And then you factored. That was our second step. What do you do after you factor? If you distribute, you're back to where we were before. It's not solved.
Yes, you solved it.
Okay, how are you doing that? That's fine. That's what we're trying to do. What? What did you say? You mumbled something.
Yeah.
Oh, okay.
Oh,
So let's go back and do like an Algebra 2 problem. Let's just say we have something like this. Right? So this is kind of like the same spot we're at in our trig problem. How do you finish solving that? This is something we should be... You can't add the 4 because of the multiplication of the x. You'd be violating order of operations. You don't want to do any dividing here. Putting... No. No. So what you need to do is called the zero product property. If you have two or more things that are multiplied together and it equals 0, you can say that either of those two things could equal 0. Okay? So you'd end up with 2 answers. What are we going to do to our trig problem then? So write cos theta equals 0, and then sine theta minus 1 equals 0. So far, so good? Okay. The cos theta, I have the trig part all by itself, so I'm ready to go to my unit circle. On the unit circle, what am I looking up? What 0, though? Where on the unit circle am I looking for a 0? Okay, looking for x equals 0. And where do you find that at? Look at your unit circles. Pi over 2, is that the only place? Very good. Okay. Now we worry about the sine theta minus 1 equals to 0. What do I need to do to get the sine theta by itself? Add 1. Okay, now the trig part is by itself, so I'm ready to go to the unit circle. Whatever am I looking on the unit circle? Y is equal to 1. What are those places where y is equal to 1? No? Pi over 2. So how many answers did we end up with? Look carefully. 2. Because one of them is the same answer repeated. that okay? This is the level of solving problem that we should be able to comfortably be able to do. Now, some of the solving problems in the homework get way worse than this. I'm not going to expect you to do those. And we will do a little bit more practice with this before I ask you to do the homework from the book. But what I am going to ask you to do today is the work on this Delta Math assignment. Where's that at? So let's do one of these as a one together. So what do I need to do to start this one? I wouldn't divide by 2 yet. I'd add the square root 2 over and then divide by 2. So I have cosine x equals root 2 over 2. At that point, I then go to the unit circle and look up which coordinate? X, because it's cosine, is root 2 over 2. My answer is looking at your unit circle, we're looking for where the x coordinate, that's one of them. So I can do 7 pi divided by 4. Is that the only place? Not that one. And then I'm going to type a comma because there's another one at pi over 4. So I have 2 solutions. I'll hit submit. Done, right? So that's one example, or one type of problem you'll have to do. Then we'll have some simplifying problems. So the directions say simplify to a single trig function with no denominator. Come on, you stupid thing. So let's do that. Okay, so to do this, where should I be looking? I have identities, right? I have either algebra thing or identity thing to do. This is just a single fraction. That's obviously, there's no reducing that I can do, so I'm looking for identities. So I either want to look for an identity that turns cotangent into a cosecant or a cosecant into a cotangent, because hopefully I can do some reducing here. Tangent is equal to 1 over cotangent, but I don't have a tangent here, right? I want to look for something that's turning a cotangent into something with a cosecant in it, or something that's turning a cosecant into something with a cotangent in it. You got it? Which one is it? Keep making eye contact and shaking your head and smiling like you have the answer, and then I ask you for what the answer is, and you're like, I don't know. It's very confusing. It's okay. You don't have to apologize. Look at the cues.
You said what was it? Oh! Q2.
Q2. What's that allow us to say cotangent is? Great. And now instead of writing this as a mega fraction, I'm going to write it that way. What do you notice we can do there? What do you guys see? Come on. Mariana, this is right up your neighborhood.
Oh, this was it.
The directions say to write as a single trig function with no denominator. There you go. I called on you because you were the reduce queen. You had all the reducing answers last time. So we've got it down to a single trig function, but not a denominator. So let's go and look for an identity. Is there something that 1 over secant is equal to?
Sine.
Okay, that is R2. It says 1 over secant is cosine. And that's what I want. So I'm going to type in cosine theta, submit. Everybody's okay? And then here's just some multiple choice questions. It says the reciprocal function of secant is cosine. Those ones should be easy, right? They're just asking about reciprocals and stuff. What do you guys think? Can we do this delta math? Okay, the remainder of time here we have here together, we can work on the delta math and or work on 47 through 62 and or some other homework assignment that you're still completing. Everybody happy? Okay.